In this example, we learned how to determine if a relationship represents an inverse variation. We see a table of values here, some values for x, some values for y, and we notice that when x equals 1, y equals 12, if we multiply by 2 that value of x, then 1 times 2 is 2. The corresponding value for 2 is half of the value that we had before. So as we multiply by 2 the x value, the y value is being divided by the same number. So we say that that is x and y varies inversely with respect to each other. And in this case, we can see that this very easily by multiplying the two values, 1 times 12, 2 times 6, 3 times 4, 4 times 3, 6 times 2, and 12 times 1. And we always get the same answer, that is 12. So that's an easy way to check when um, a table represents an inverse variation. In this case, the product or multiplication is, like I said, 12, and we can say that this is representing an inverse variation. So in this particular case here, we do the same. 1 times 20 is not the same as 2 times 17. 1 times 20 is 20, 2 times 17 is 34. So pretty quickly, we can realize this is not an inverse variation. So that's how you can quickly determine if two variables uh, have an inverse variation relationship. So with that in mind, let's try to answer these two questions. Pause the video and be ready to check the answer. Obviously, you're trying to multiply those numbers using the calculator. If those answers are always the same, then you can say yes, they vary, they they represent an inverse variation. But if they are not the same, then you will answer no. So hopefully everybody did it. And product of values is constant. That means doesn't change. So it should be an inverse variation. And now do the same. Pause the video, do the multiplications, see if you always get the same answer, and answer accordingly. So in this case, the products are not constant, those are different, so this does not represent inverse variation. So this is the first example we'll deal with. We'll go from here to example number 2. But before, we want to talk about a concept. So when a relation between x and y is an inverse variation, we say that x varies inversely as y. Inverse variation is modeled by the equation y equals k over x. Notice that in this case, if we multiplied by x on both sides of this equation, we will get x times y equals k, which is constant. So that means that when you multiply the two variables, the answer is always the same. So we can express the same relationship by doing y equals k over x or x equals k over y. And this is a good example here where all the multiplications or products are always the same. So please keep that in mind. Um, example 2 is asking us about to write an equation, keeping that in mind. So if we know that when the value of x is 10, the value of y is 3, we know that the product needs to be always 30. 10 times 3 is 30. So we can write y equals 30 over x, and then we can replace the x by -6 to find the corresponding value of y. That is the plan that they follow here. So once again, the constant of proportionality, that's what this number k is called, is 30. So we can write that one number equals 30 divided by the other number. Remember, we can even interchange x and y, and that would be the same equation. So if given the equation, the general equation, you can just plug in x equals -6 and you will find y equals -5. So I want to call your attention to the easy way to answer the question even without following this process is finding a number that times -6 equals 30, because we know that 10 times 3 is 30. We know that all multiplication should be 30. So if we just divide 30 by -6, we will get the other number, which is -5. So let's pause there and please try to answer the two questions, knowing that this is inverse variation. If x equals 6 and y equals 1/2, what is the equation, first of all? So remember, you multiply, that's the constant of proportionality, and then y will be equal to the constant of proportionality divided by x. That's the general equation. And then, of course, you can plug in x equals 15 to find the corresponding answer for y. So hopefully everybody did it right now. And of course, 6 times 1/2 is 3, and 3 divided by x will be equals to y. And over here, when you plug in x equals 15, it'll be 3 over 15, which simplified will be 1 over 5. So let's check it here. All right. So let's leave it like that for right now.